All right. Initially, two large tanks, A and B, represented on the right, each hold 100 gallons of brine. The well-stirred liquid is pumped between the tanks as shown. Use the information given in the figure to construct a mathematical model for the number of pounds of salt of x1 of t and x2 of t at time t in tanks A and B respectively. Okay, so for tanks, we need to look at the tanks individually. And remember that the rate of change of salt, let's say x over time, is going to be equal to the net rate in minus rate out, so the net rate. So what is the stuff that's coming in? Well, let's look first at this tank over here. What we see is that we have 7 gallons per minute going in from the top left. So 7 gallons per minute. And we want to multiply this by the concentration. Well, what is the concentration? Well, they gave it to us over here, 2 pounds per gallon. So 2 pounds per gallons. And what else is coming in? Well, we got stuff coming in here. So that's going to be another plus. And we have what? 1 gallon per minute. Now, it says mixture. So it means that its concentration is related to this. I don't know that one, but I'm going to say that the amount of salt at any times t in tank B is x sub 2. And to multiply by the concentration, because here we multiplied it by pounds per gallon, we need to divide by the volume of water, which we said we start at 100 gallons. And now we need to see if we also end at 100 gallons. So we need to add what? Well, the amount of gallons that are going in at any one time minus the stuff that's going out, which is 1 gallon per minute and another 4 gallons per minute. And then, depending at what time it is, these are going to have different values, t. Okay, so that's the stuff going into tank A. Now let's look at the stuff that's going out of tank A. So we'll do the stuff that's going out in yellow. The stuff that's going out of tank A is going to be, we're going to put a minus and then a big parenthesis here. I'll put a square parenthesis. And we have from the top 5 gallons per minute going out at a concentration of the stuff that's in A, so the amount of salt in A, which we denoted as x1, divided by 100 gallons initially, plus all the stuff that gets in, which is 7 gallons per minute, plus from the bottom 1 gallon per minute, minus the stuff that's coming out, which is 3 gallons per minute, 3 gallons per minute, and minus 5 gallons per minute. And that's going to be from the top right. Now from the bottom left, we're going to add plus the mixture coming out from A, which is still x sub 1 divided by 100 gallons. And I'm not going to rewrite the whole thing because I noticed that this, first of all, I need to put a t in here. But this becomes 0. And this becomes 0 too. So it's saying that the net amount of water in there, of volume in there, is always constant because the stuff coming out total is equal to the stuff coming in total. So this is for tank A. Now, armed of this knowledge, we'll do for tank B. So the stuff that was going, for tank B, we'll use this color for all of tank B. So this one ends up being for dx1, but dx2 over dt is still going to be rate in minus rate out. But now it's going to be for tank B. So the stuff that's coming into tank B is just 5 gallons per minute multiplied by a mixture, which is the mixture of A. So the amount in A divided by the volume, which is 100, and it'll stay 100 because of this. And then we have minus stuff coming out. Again, we have 1 gallon per minute coming out from the bottom left, multiplied by the concentration, which is the amount in B divided by the gallons in B. And then we have plus, because the minus is already here, plus 4 gallons per minute going out times the mixture of B divided by 100, again, because it's not changing. But don't make this mistake. Remember to always check if it's changing or not, because if it is changing, it changes the problem. So now that we have this, what are we gonna do? We're going to simplify this and clean it up a little bit. So I'm gonna say x1 prime is equal to, here we have 14, I'm gonna drop the units, plus x2 over 100 minus 5x1 over 100 plus x1 over 100. And then here, for the second one, we'll have 5x1 minus x2 over 100 plus 4x2 over 100. So now I can simplify similar terms like this and this, and I can rewrite this as, and I'll write the x1 first. I can rewrite this as negative 4 over 100, which becomes minus 1 over 25x1 plus 1 over 100 x2. Don't forget that 14 at the end. And then here we have 3 over 100. Well, we have 5x1 plus 3 over 100 x2 plus 0. So we can rewrite this in matrix form, picking out the coefficient matrix now that it is ordered, 5, 3, and 0. And here we have x1, x2. And this is our model. So I hope this was useful, and I also hope I didn't make any mistakes. And I'll see you next time.